Improve your Go programming skills by developing 3 different projects. In this Go course, experienced developer Akhil Sharma will teach you how to build a website health checker, a program to encrypt text, and a program to encrypt files.
Hey guys, in this video we are building 3 awesome projects with Golang. Now these are beginner friendly projects and awesome additions to your portfolio in case you're applying for a Golang job. In the first project, we're going to be building a Golang health checker where we'll check the health of a website. So you'll just have to enter the domain name of a website and you'll come to know if it's live or it's down. The second project is about encrypting files. So we'll start with the PNG file and we'll encrypt it. We'll try to access it without the password and then we'll access it with the password to see how encryption works. The third project is about encrypting a string with Golang. So all these 3 projects you'll learn quite a lot of Golang. So if you have basic Golang skills, you'll be able to refine your skills and build on top of that knowledge. So let's get started. Hey guys, welcome back. In today's video, we are building a very simple project. We're going to build a Golang project which checks if a website is running or it's down. And accordingly, we'll show the appropriate message in the terminal saying the website is up or running or it's down or not running, right? And you'll find these kind of projects very easily on Google. If you go and if you check if is the website on, there are many projects like these and they basically run it free of cost, but then they show ads. So if you want to do that, we can do that as well. But it's just a great project to build and to basically practice your Golang skills, right? Now this project is going to be a part of the Golang playlist, Golang project playlist. So in my YouTube, if you go to the playlist, there's a Golang playlist. Right now it has 46 projects. So I have called it the 46 killer Golang projects playlist. But then the number keeps changing. So once I put this video, it'll be like 47 Golang projects, right? So depending on when you watch this video, the number would have changed. But then it's important to know that that playlist exists. And you can, and what I'm trying to do is I'm trying to arrange those projects in the increasing level of difficulty. And this project, since it's very small and very simple, we'll place it towards the beginning of that playlist, even though I'm releasing it quite at the end, but I'm going to actually position it towards the beginning of the playlist. Okay. So with that out of the way, we can get started. I'll show you a couple of diagrams just to help you visualize what you're building. And then we'll just go ahead and build it. All right. Now, just before we get started, I just want to tell you that a very common name for this project that we're building is called the health checker, right? So for any project that you're building, you might also want to create a health checker microservice in case you don't want to launch this as your own project on the internet. Completely fine. But usually when people build, let's say a project, and then they usually build a microservice which checks health of their own project. So with the project that we're building, you could do that, like check the health of your own project, or you could check the health of any website that's up or down. You can check that status of that website. All right. Now we can get started. So now I think you can see my screen. Here we've just represented what we'll be doing in our code. So we have a main.go file which will have the main function. And all we're doing is importing the CLI package. So it could be any CLI package, like you could be using something like Cobra or something like that, but I'll be using something very small and basic in this project because this project is small, right? And we'll be passing 2 things. We'll be making use of 2 things. One is the flags. So we'll set 2 flags, which is the domain and the port. And the action for the CLI tool would be to call the check function. Okay. The check function is going to be defined in a file called check.go. It's going to accept destination and port because that's what we'll send from here to this function, destination and port. And the whole business logic here, or the crux of the entire program, is the dial timeout function. So this function you get in this package called net, the net package, very popular package to work with web related things in Golang, right? So we'll use the dial timeout package, and finally we will return the status of the website, whether it's up or down. So that's the entire business logic here in the project. So now let's go ahead, create a new project and get started. All right, so now we'll start building our project. Everything that I'll be showing you in this video is already there in my GitHub account. So make sure you check out Akhil Sharma 90, which is my username on GitHub. All the projects are there. Check out the code in case you get stuck somewhere. We'll just create a new directory called Go Health Check YT. So we'll cd into it, and what we'll do is we will go mod init, and I'll just give it my username /go health check YT. Okay, so now you can see the go mod file already has been created, and we will just open up our VS Code and check out that everything looks all right. Now I have decided upon the package that I'll be using. It's CLI version 2, and I found it on this project, on this profile called YourFave. This is a common package. It's very light, so if you're not building something huge like a proper CLI tool, I recommend using something like this, something very light like this. There are thousands of packages like these, by the way, but if you're building something serious, then obviously Cobra CLI is the way to go. Anyways, now we'll create two files, as you know. One is the main.go file, and the other is our check.go file. Okay, in the main.go file we will do the regular stuff, package name, import, the import statements and all of that. And in the import, I want to put this package so that it's clear that we're going to use it. And then you have your func main. That's how you start. That's the most important part in your main.go file, obviously. And I'm going to go ahead and create app, which is basically CLI.app, right? CLI being the package that I'm using. And this helps to create a complete CLI tool where I can give it a name, I can show how the tool is used, I can give in the flags. We've already talked about the flags, and I can talk about the action. What's supposed to happen when the right commands are, or the right commands are given. What's the action that's supposed to happen? All right. So now for the name, what we'll say is let's call it health checker, and the usage uses basically basic text on how this product is going to be used. So I'll say a tiny tool that checks whether a website is running or is down, and then there are the flags. So CLI.flag, okay, and here you have the name, which is domain, aliases, string D, and the usage, which is this is where you'll enter the domain name, like for example google.com. That's the domain name to check whether it's up or down. So that's the domain, and it's required, so we'll say required is true. Without this there's no point of the app if you don't have this, right? All right, so in the flags, there's one more flag that we're going to have, which is the CLI.string flag. It's going to be, name will be port, aliases string B, usage port number to check, and required false. Right. Now for the action, you're going to have CLI.context, and we might return an error. And let's define the port, which is c.string and the port, and if c.string and port is null, which is empty, then the port will be 80, right? So what's happening here, which is standard, basically whenever you check anything, you're checking on port 80, which is like the most common port, right, where the handshake would happen anyways. But let's say you can say any port, you can mention any port here, but if you have not mentioned any port here, the default port, which is 80, which is the one that's always checked, that's the one that will be set, right, for the port variable. And then you have status is equal to check. So this is the check function I was talking about, which we will create in the other file called the check.go file. And you're checking the domain and the port. So we're sending two things to the check function, which is the domain and the port, which is what I had shown you in the diagram. And we're going to print the status and return nil for the error if everything goes well. Here we'll say error equal to app.run. Okay, so you say app, which you just created, the whole app using the CLI package, and you're going to say app.run, passing in the OS arguments, and you're also handling the error. So if there is an error, you can do something about it. If the error is not equal to nil, that means the error is there. You'll say log.fatal and you'll print out the error. All right. And now we can work on the other file, which is check.go. So now we're going to go ahead and create the check.go file. Before that, what I'll do is I'll just say go mod diary just to create the go.sum file. But there seems to be some problem. We'll fix it, no problem. So right now, let's just create the check.go file. Okay, so we'll say package main, because it's also the part of package main only, not creating a separate package. And here there are a few more packages that I've used actually, like FMT and all those, and somehow they've not come up. So usually when I save the files, they come up. Like my plugins are not working, I think right now. I'll just copy and paste them on my own anyways. Alright, so here also I'll need some packages, so I'll just say fmt time and net. The most important one obviously here is the net package. You know that because the net package has the dial timeout function that we'll use to actually check the status of the website. So we'll say func check destination, it's a string, and port, which is a string, and it returns a string being the status. So we return the status from the check function. So here we'll say address, it's equal to destination plus port, right? Destination being the domain name and port being the port that you pass in, or even port 80, which is the default, right? So we'll say for the duration of 5 seconds is our timeout. So within 5 seconds, if you get a response back from the website, that means the website is on, otherwise it's not. Okay, this is the main part, which is we're using the net package and the dial timeout function. We're going to send in the address, which is basically the destination and the port both combined with the timeout, which is 5 seconds in our case. And let's create a variable called status, which is the one that we're going to return from this function. And here, this error that we have, which is we're checking, we'll have to now check for that error. So we'll say if error is not equal to nil, it means there is some error, then we'll say status would be fmt.sprintf down website is not reachable. So to print out the name of the website, star v, percentage v is unreachable. The website is not reachable, and you can print out the error %v, and here the actual variables, which is destination and the error, right? Else we'll say status equal fmt.printf, and we'll say up %v is reachable. Basically the website is reachable, and then we'll print out from which address we had tried to which address. That means the destination, comma, connection dot local address, right? So your connection variable will have a copy of the local address, the address at your end, which is making the request, and the remote address, basically the website and the port that you had mentioned just above. And finally, going to return the status. Okay, so all okay here, I think. To get rid of the error, just remove this quickly and let Golang do it for you. So just say go mod tidy, it'll get all the packages, right, that you're supposed to have, and it'll also generate the go.sum file for you. Here in the main.go file there's an issue because there's a small spelling mistake. It should have been aliases. And but I see one more error, so let me quickly check. Yeah, the other thing is that there's another spelling mistake here. It's CLI. Alright, so hopefully everything should be fine now, but I still see one more error. Alright, so yeah, that's one more issue, which is spelling of name is wrong. So just save it. Everything seems fine now to me. Here, so by flag, you know what you mean by flag is that when we run this tool now, we'll have to pass the flag. So let me actually show you how to do it. So we'll say go run dot -- domain, which is the flag now in our case, and it could be pexels.com. So it's saying it's reachable, right? So if you say google.com and amazon.com, yeah, so all the websites are up at the moment, all of them are reachable. All right, so that was our simple yet effective tool that we've built, and we've done quite a bit in this tutorial. It's a very tiny tool, but then a lot of concepts have been used here. So I hope you've learned quite a bit. Thank you so much for watching. Do make sure you watch all the other projects in this series because there's so much to learn, right? And thank you so much for watching, and do subscribe. Hey! In today's video, we are encrypting files with Golang. So in my root directory of this project, I have the img.png file, which I'm going to now encrypt. So as you can see, I can see the file now, right? But if I encrypt it, so I'll say go run encrypt, and I'll say img.png, which is the name of the file I want to encrypt, and I'll enter some password. It'll confirm the password and it'll encrypt it for me, and it'll say file successfully protected. And now, as you can see, I can't see it anymore. I can't see the file anymore. But now, if I go and if I just decrypt the same file, it will ask me to enter the password. It will say file successfully decrypted. And now again, I can see the image. Awesome, right? So how is this happening? So let me take you through it. So in the beginning, what will happen is we will accept the arguments from user, which is basically the file, the path to the file or the file name. We'll validate if the file even exists or not, and we'll also ask the user for the password, and we'll validate the password in the sense if both the passwords match. This is for the encryption part, right? We'll check if both the passwords match, password 1 and password 2. Then we'll encrypt the file, and then for decrypt, we'll again check the password, and after getting the password, we'll check the password. Okay, so it's really straightforward. From a 10,000 feet perspective, this is what's happening. We're just getting arguments from the user, validating the file, getting the password from the user, encrypting the file by validating the password, and then decrypting the file with the same password. That's what's happening. But if you look if you look a bit deeper, then you have two parts, encryption and decryption. In the encryption part, we follow multiple steps. So we first check for the source file. We open that source file, the one with the plain text, which was our img.png, and then we'll read that plain text. Now it could be the data from the PNG, or it could be a text file, right? Well, whatever it is, it's basically plain data from the source file. Then we'll create an empty variable called a nonce. This will be 12 bits or 12 bytes in our case, and we'll randomize it. So we'll create a random, basically 12 byte variable, because we want to use it later on. So firstly, you have the password that we'll use to encrypt the file, right? So the password, and then there's something called as the byte length, in the sense what do you want to get after running a derivation function. So we'll basically be running a password based derivation function. I'll talk more about it. But the first thing you need is a password. The next thing you need is the byte length. In our case, it will be 32. Then the algorithm with which we want to encrypt it, and the number of iterations. In our case, it will be like somewhere around 4,000 iterations. Iterations basically make it more difficult for the party that wants to hack this or break the encryption. It just makes it more difficult for them. Okay. So with the password based key derivation function, this is a function in which a key will be generated from the password. So we'll take in the password and we'll add in a few different things, as you can see, and we'll get a key, and this can be used as an encryption key or the hash value. So we're basically just hashing the password. Now this is very similar to how you take the user's password, you hash it, and then you store it in the database, right? Because you don't want to store the passwords directly in the database, because otherwise people can steal or get access to the database, steal all the passwords, right? So you always hash the passwords with some salt, and that's what's happening here, right? So this is the salt in this case, the nonce. So with the password based key derivation function, you get something called as a derived key. Now the derived key, we'll run it past AES or Advanced Encryption Standard. This will give us some solid encryption abilities after getting that key from the password. And this, by running it through the AES cipher, we'll get something called as a cipher block, and that again we'll run through something called as the Galois counter mode. Now this is spelled as Galois, but I think this is like a French word, so you say Galois or something like that. I'm not French, so I have no idea. So it's the GCM, I call it the GCM, Galois counter, whatever, blah, 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 but it's GCM basically, right? And GCM gives you more encryption with data integrity checks. Now, GCM generates a tag which is appended to the ciphertext at the end, and this tag is used to verify the integrity upon data encryption. Now, you had some data, you encrypted it, but then how do you know that the data that you got back is actually the correct data? And that's why we are using GCM, because that gives us the tag to verify the integrity of the data upon decryption. And GCM uses AES. So as you know, we have already used AES before. It uses AES to encrypt the plain text. This operates in a countered mode, and hence the name, and generates a stream of encrypted blocks. That's what GCM does. Finally, we use this function called AES GCM, which AES GCM is what you get. So you already had the AES cipher, which is the cipher block. Then you run it through GCM, you get AES GCM, and you run this function called AES GCM.seal. This is the main function. Now this is just to use this function, we had to do all of this, basically all of this part, because we wanted to run this function called the seal function. And the seal function is what takes the plain text from our file, from our img file or any other file, and converts it into ciphertext. And it then creates a source file for encrypted data, and we write ciphertext to the new source file. So the file in our case remains the same, but then again we have to create the source file for the encrypted data and write the ciphertext. Ciphertext is basically text that we can't then access, right? So that will be written to the source file. So that's the encryption. Now let's go over the decryption. For the decryption, it's very, very similar. we'll check for the encrypted file. So here we were checking for the source file that had to be encrypted, and now we'll be checking for the encrypted file, because to our program we will be saying that, hey, this is the encrypted file, please decrypt it for me. So we'll check for the encrypted file, we'll open that file, we'll read the cipher text from the encrypted file, right? The text that we can't open in our IDE, but it still can be read from our function. Now, to convert the cipher text into regular plain text, we have to again run the password based key derivation function. So we'll have to have the same password which we use to encrypt, we'll have to have the same password to decrypt it as well. Same byte length, same algorithm, SHA-1, and the number of iterations should also be the same. And then the nonce, as you remember, we created a nonce here, a randomized nonce, and the GCM basically appended the nonce to the cipher text, and exactly that's what we want. We want to get the nonce from here, which will be at the end. So the last 12 digits of the encrypted file will have the nonce. We want access to that. So all of these 5 things we'll pass to the password based key derivation function. We'll get the derived key. Again, the same thing, AES cipher, we'll get the cipher block, GCM, we'll get AES GCM. Now we did all of this. So this was important. Obviously, you know that you have to use salt to hash the password. This is perfect, but these extra steps we only did because we wanted to use this AES GCM.open function, which takes in the cipher text to this function without the nonce, obviously, and gets you back the plain text. Now the plain text is what you will write again to a file which will have the decrypted data or the plain text, and that's the one that you will write back to the file, and that's how you'll be able to read the file again. So that's what's happening in your encryption and decryption. So in our program, in the code, what we'll need to have is we'll need to do all of this, like the whole entire logic for the encrypt function and the entire logic for the decryption function. And I'll keep opening this diagram again and again in between, just so that we are able to refer it while we are writing the code. But the program also needs to do all of this. So we'll the way I'm thinking of it is that I'll need one file which will have the encryption decryption functions, and I'll need one file which is the main.go file, which will have all of this thing, which will print out stuff to the terminal and accept values from the user from the terminal. So all of that logic I'll put in main.go file. Okay. So now we can start writing our code. Now before we start writing our code, just want to tell you that on my channel, this particular video that we're creating right now will show up in the 48 Killer Golang project series. So this is a playlist which basically is which has 48 projects now, but I'll add this one, so it'll be 49 projects. And this playlist, right, is in the order of difficulty. So we have smaller, simpler programs earlier, and then more difficult programs later on. This will be somewhere in the middle. It's not, or somewhere towards the end, but not at the complete end, because this is not very difficult to build what we're building today. Just make sure you go through all the videos in this playlist and you build them one by one. And once you've done that, you will know Golang better than 90% of the people, or 99% of the people actually out there. Because I mean, how many people do you know who build like 50 projects with Golang, right? Not many. So this will seriously give you an edge if you build all the projects in this playlist. All right. I also wanted to tell you one more thing, that if you go to my channel, you get access to this Discord link here. As you can see, this is the Discord link for this community out here, which is where we discuss a lot of stuff around Golang, and we share our learnings, what we've been learning today. We have a lot of forums where we discuss issues that we're facing, blah blah blah. So a lot of stuff here. So a lot of cool discussions happening. So make sure you join this, because I mean, if you want to learn Golang, this is the right place to be. This is the right community to be at. All right, because I'm here quite a lot. As you can see, it's always open on my browser these days, so I'm always there replying to messages. All right, so I have now talked through all the things that I wanted to talk through. So now is the time to start building the project. What I'll now do is I'll create a new directory called Go File Encryption. By the way, this project already exists on my GitHub. So in case you are already following me on GitHub, you will see this program there, the file encryption one. In case I don't put the link to this project in my description of this video, please know that my GitHub is akhilsharma90, AKHIL SHARMA 90. The project is there. In case you get stuck somewhere, you can access the code, you can look at the code and build along with me, right? So here I will cd into it. I will cd into go file encryption, and we will say go mod init github.com/sharma90/go file encryption. This creates a go.mod file for us, which will have the list of all our dependencies, and I will just go ahead and open this up in my code editor. Here I'll just create a main.go file, and I'll create a folder for file crypt, and there will be a file called filecrypt.com. Okay. Now I told you that I'll divide the logic into two different parts. One will be the interfacing with the user part, and the other will be the actual encryption and decryption. So let's talk about the part where we'll accept user values. So we first start with, package main, not make. We start with package main, all right, and there will obviously be func main, which is from. So main is the most important file, main.go is the most important file, which is obviously the main package again, and then it has the main function, which is where the program begins from, or origins. Everything starts from here, and then this is why from this function we have to call all the other functions. This is like the root or the source of everything. Then there will be an import statement here, and I'll import multiple packages in a while. So firstly, I want to check if the length of the arguments. Now to work with arguments to print out messages to the CLI, we could use something like Cobra, which is a CLI tool, and I already have projects with that, I think. That's very commonly used in Golang, as you know, Cobra. We are not using it here because we have like very few operations, and we can do that on our own. We don't need to import a complete library just to print out stuff to the terminal and to work with some arguments, right? And here we're just checking if the length of the arguments is less than 2. If it is less than 2, then we'll print help. In print help, we'll basically print out, so there's a function called print help. It's print help, which basically tells the user on how to actually use this project. So if the user is not entering, let's say, encrypt or decrypt and the name of the file, that means he doesn't know how to use this function, right? So he'll just print help out in that scenario. And the other thing is function equal to os.args1, and we'll switch function. So what do you want to do? So do you want help? If you want help, we'll just print help. We'll just call the print help function. If you want to encrypt, we will call the encrypt handle function. If you want to decrypt, we will call the decrypt handle function. And then there is a default, which is run encrypt to encrypt a file and decrypt to decrypt a file, right? Just telling the user that, hey, please run encrypt to encrypt the file and decrypt to decrypt the file. Okay, so that is our main function. Now, as you know, we're calling 3 functions from the main function, which is the print help, encrypt handle, and decrypt handle. So we're going to create all those functions. So we'll have the encrypt handle function, and we'll have the decrypt handle function. There are three more functions that we'll need in the encrypt handle. There is the get password to get the password from the user, and then we have the validate. So we have the get password function, we have the validate file and validate password functions. So let me create those. Validate password and func validate file. Okay, so in the print help is going to be very straightforward. So I'll just go ahead and copy and paste. Actually, you don't have to write this whole thing on your own. So this is basically saying file encryption, simple file encryptor for your day-to-day needs, which is the name of the program, and then what it does, and then showing you usage that you can go run. And when we say dot, basically means it runs all the files in at the root, which is our main.go and also our file.crypt.go folder or package. And it will basically you want to pass the path to your file. In our case, we'll just say img.png, which will be a file that I'll copy and paste here. You can copy and paste any file here. I'm just using this Apple file here. And then you have the commands like encrypt, decrypt, and help. We'll have three commands. Encrypt will encrypt a file with a given password. Decrypt tries to decrypt a file using a password, and help, which displays the help text, which is this particular function gets called there. Now for the encrypt handle, which is the most important one, the encrypt and decrypt actually are both really important because that's the logic, main logic. So here we'll check if if the length of the os.args is less than 3. That means you have written that you want to run the program and you want to encrypt, but you've not passed the path to the file, right? So its arguments are less than 3. Then you will print ln. You will print out missing the path to the file. For more info, run instead of encrypt, we'll say run the help command. All right, and os.exit 0. If everything is all right, then what you want to do is you want to get the arguments, or which is basically the arguments at the second index, which is the third argument, which in our case is the path to the file. You want to get it in this variable called file, and you want to validate. So if not validate file, and you pass the file there, and you just panic file not found. So what happens in the validate file function when this gets called? Basically it takes in the file, which is string, and it passes back a boolean, which is, that's how we are checking it here, true or false. This exclamation helps us check that. So if it's not valid, then we say file not found. Okay, and how does it return the boolean? It's basically using the os.stat function on the file and saying if header equal to os.is not exist, return false. If it doesn't exist, return false. If it exists, return true. That's how we're checking for it out here. So for the encrypt part, we have checked the validity of the file and not found. Now the next step is to ask for the password. So we'll say password is equal to get password. Right, so we already have the get password function. So what does it do? It returns the password, which is a slice of bytes. And how does it accept the password? It says first it prints out enter password, then it's going to use the terminal package to read the password and going to capture that in the password variable. So if you remember, when we were encrypting the file, we didn't only just accept the password, we also asked the user for the confirm password, as in confirm this password. So you want to print that out as well. So you're going to say /n confirm password, and we want to again read the password. Okay, and this will be password 2. And here is where we will validate if the password 1 and password 2 are the same, they're matching. So we'll say if not validate password, which will pass password 1 and password 2. Basically this function, the validate password function, should return back to us a boolean. And here we'll say fmt.print passwords. Do not match. Please try again. Return get password. If the passwords don't match, we want this function, the get password function, to be called again and again ask the user the passwords. If everything went well, we just want to return the password from here, which is a slice of bytes. Okay. Now in the validate password function, let's come here. So it's going to accept something called as password 1, which is a slice of bytes, and password 2, which is again a slice of bytes. Return back a boolean, and in here we want to check if the bytes are equal, if everything is equal in password 1 and password 2. If it's not equal, return false. If it's equal, return true. So that's our return validate password function, which got called here. And we'll go back now to our encrypt handle. So after calling the get password function, we will say fmt.println. We'll inform the user that hey, we have started encrypting the file. So we'll say encrypting, and we'll use the file crypt package. The file crypt package is our own. We'll create the file crypt package out here. So we'll say file crypt dot encrypt, because we'll have the encrypt function. We'll pass it the file and the password, and we'll print out fmt.println. We'll say file success fully protected. So that's our encrypt handle function. Now in the decrypt handle function, we will again check the same thing, which is this, like has he given us the file, the part of the file. If not, we want to exit, and we want to then validate the file again, and we want to ask the user for his password. So we'll say fmt.print enter password, and we want to say password terminal.read password, And after taking the password, we'll just print out, instead of encrypting, we'll just print out decrypting. And instead of encrypt file, the encrypt function, we'll just call the decrypt function, passing the file and password. And here, instead of protected, we'll just say decrypted. Perfect. So we have the encrypt handle and decrypt handle functions perfectly ready. Get password, validate password, validate file, and encrypt handle, print help, and name. Now, in the import statement, we should have all the files, which FileCrypt is my own package, which I'll get from here. The xterm package is the one that we're using here, term, the one that we're using to read the password. And then we have bytes, FMT, and OS. Okay, so that's how it is. Now I can already see some issues and errors, and some of them should go away once I've completed my filecrypt.go file. But then there will be many others that we fix, not a problem. And now let's go ahead and start working on our filecrypt.go file. So starting with the filecrypt.go, this package is going to be called filecrypt. And we'll import some packages, of course. Then we have two functions. One is the encrypt function, as you know, and the other is going to the decrypt function. Okay, because from here we are calling the encrypt and the decrypt functions. So in the encrypt handle and decrypt handle respectively, you call the encrypt function from filecrypt and the decrypt function from filecrypt. Those are the ones that we're working on at the moment. So in the encrypt function, you take in the source, which is string, and the password, which is byte. It's a slice of bytes. Okay. So now this source in our case is the file, right? Because if you check here, we're sending the file and the password. So file and the password, right? So for the file, we want to check if the file, let me actually open up the browser and show you the diagram again, and we'll follow the exact same steps. So here it is, we'll check for the source, open the source file, read plain text from the source file, create an empty nonce, randomize nonce. Let's do those steps. So first is os.stat, then the source, os.is not exist, and if it doesn't exist, we are just going to return an error. So first we checked for the file. Now we'll open up that file. So we'll say os.open source, and we'll capture that or store that in source file. And if error is not equal to nil, panic error. At the end of this program, when this function stops running, we want to also close that source file. So that's why we'll say differ source file.close. Now we'll read all the plain text from the source file. So to read the plain text from the source file, we'll use io.read all and source file. What you get back is plain text, and now we'll handle the error also. If error is not equal to nil, panic Now the password that you have, you want to store it in a variable because we want to work with it. So we'll say key is equal to password. And now we'll create an empty nonce. So this is an empty nonce make, and it's a slice of byte and of 12. So it's going to look something like this. It will be 0, 0, 0, right? 0, 0, 0, 0 till 12. So 12 different values, all of them 0. That's what you create with this now. And now we will randomize the nonce. Okay, so we have created the empty nonce. Now we'll randomize it. We'll put random values in it. And the way to do that is we'll say io dot read full random dot reader. So fill it with random values, and error is not equal to nil. Panic error dot error. Awesome. What's the next step now? So on my screen, the next step is we pass all these values to create into the password based derivation, key derivation function. Okay. So the password based key derivation function is available to us in a package of the same name, pbkdf2, and that function we pass the key, the nonce, 4096 as the number of iterations, 32 as a length, and SHA1.new as the algorithm. So if you look here, we are passing the password to encrypt the file, the nonce, the number of iterations, SHA1, and the byte length, which is 32 in our case, and this is the number of iterations. What you get back from this is called as the derived key, DK. So just in short, it's DK. This package that we're getting everything from is this package, pbkdf2. So now we have the derived key. Now we will run it passed by the advanced encryption standard. So we'll say AES.new cipher DK, and we'll get the block and we'll handle the error also. So we'll say if error is not equal to nil, panic error. Okay, so we have this now, the cipher block, and now we are going to use the Galois so whatever it is, GCM, I'll call it GCM. So it's the new GCM function. So I'll say cipher.new GCM function, and I'll pass in the block. And what you get back is AES GCM if error is not equal to nil, panic error dot error. Okay. So as you know, we did all these steps to be able to run the seal function here, which is what creates the which is what converts the plain text to ciphertext. So coming back here, let us use the AES GCM dot seal function. This is what's going to take the plain text for us and send back the ciphertext. And you append the nonce. So there is one thing that I have not drawn here, but I have actually talked about it here, is that we add the 12-byte nonce at the end of the encrypted file. So we want to do that now. We want to append the nonce to the ciphertext. And store that in the ciphertext itself. So now we have the complete ciphertext. Now I'm going to create a file. Source file for the encrypted data, and we want to write the data to the source file. So what you'll do now is we'll call it the destination file os.create, create that file, handle the error also here, panic, and at the end of this function, when this function has done processing, you want to close this file as well. So you have created the file, now you just want to write ciphertext into that file. So write the ciphertext into the file, but this is the destination file, so we'll say destination file.write, and you will get the error, if any. If error is not equal to nil, panic, error. Okay. So this was our encrypt function. So far so good. And as soon as I hit save, it got me all the packages that I needed. And now we want to work for the decrypt function. The decrypt function is very similar. It takes in the path of the file and the password, with the help of which we will decrypt this. And first things first, you want to check if the file that's to be decrypted, the request that's coming for decryption, if the file even exists or not. So do the same thing, os.sat source os.is not exist error, and here you will, this is the error you're handling here, and you're just saying panic error. Okay, and actually some of the part from here is going to be similar, so I will just copy this part, all of this part till here. I'll just copy it once again after this. So here you will have src file where you'll open that source file, and at the end you will close it also. And here, instead of plain text, you'll just have ciphertext, because that's what is in the file now, because you have already encrypted the file and you're passing the encrypted file to this decrypt function, and that's why whatever is there in the file is now ciphertext. So we have done in the decryption part, we're done with this. Check for the encrypted file, open the encrypted file, and read the text, ciphertext from the encrypted file. All of this is done. Okay. So the password that you will receive in this function will again be stored in the variable key, and then we'll have a variable called salt, which will basically have ciphertext and length of cipher. So without the last 12. Okay, and x dot encode to string. The salt, which is basically the nonce, the last 12 is the nonce, right? You'll have it in salt, and we will use the hex package to decode this string. And we will store that in str. Sorry, this will be nonce now. Okay. Okay, so what do you pass again in that function? The password based key derivation function for decryption. You pass the same password to that will be used now to decrypt, the byte length 32, chart 1, iterations 4096, and the nonce that we got from the last 12 digits of the cipher text. And the same thing you do here, you say new cipher, new AES.new cipher, and you pass the derivative key, and you'll again get the block, and again you can handle the errors if error not equal to nil, and then you want to pass that block to the cipher, AES cipher. So what I'll do is we've already done that, and now we want to pass it through the GCM, sorry. Yeah. So the same thing that we've done there, we're doing it here. And now there's only one little difference, which is that instead of using the AES GCM dot seal function, we'll just use AES GCM dot open function. So here we'll have the nonce, the ciphertext, which is everything apart from those last 12. And what you get back from this is the plain text. Okay, so what you're seeing now is step by step, we're just looking at the diagram and we are converting the diagram into code. Okay, so our flow chart into code. Again, let's handle the error here, and then we'll again create the file like we did last time, the destination file. So I'll copy and paste that part here, and now we will write plain text to this file. So instead, here we wrote the ciphertext to the file, and now we will write the plain text which we have received to the file. So here what was happening in the encrypt function, what was happening is that you ran that function called the seal function, which gave you the ciphertext. To run the seal function, AES GCM seal function, you had to do all of these steps, which is get the plain text and then create your nonce, have your password ready, create a derived key with PB KDF function, use advanced encryption standard, new cipher, create a block, cipher block, pass the cipher block with GCM and get AES GCM, and then you were able to call the seal function to get the ciphertext with all those values. Here exactly the same things. You just had to call the AES GCM dot open function because this will give us the plain text from the ciphertext. Ciphertext is everything apart from those 12 last digits, which actually was the nonce in our case for nonce, right? The salt, which we can convert into nonce here. And then finally, just like we did in the encryption file, we created a file and then we wrote plain text back into that file. And now when we open up this file, we'll be able to access it, right? So as you can see, I have a lot of errors and I'm not at all scared, because now when I go ahead and run this program, I will come to know what the issues are. So I'll say go run encrypt .png, and here I see all of these issues. It says file crypt, to add file crypt, and yeah, so xterm and file crypt are not there. That means I need to say go mod tidy. So first I'll get these packages. I can see some issue there, but let's see if it still works. Yeah, still the same issues I'm getting. So let's try to fix it. Now one issue out here obviously is this part, which is I've copied the link from my previous project. Now this is obviously my GitHub, and this should be the name of the project, right? And I'm calling file crypt package, but the name of the project is wrong. That I have to go and get from go mod. So the name of the project is actually go file encryption in this case, and I have to go and get it here, and this issue will go away. Now what we'll do is we'll again go and run go run encrypt img or png, and now we'll get a list of issues. Okay, so now on line 68 file crypt, as I can see, it should have been error. Okay, now let me check out line 83. Line 83, key is not used. Yes, because I was supposed to use key here. By mistake I've written name, and here also I can see one more issue. It's key, should have been key, right? Now the other thing I can see is 88, which is undefined. Yeah, it's the same thing. This was the issue, line 88. Alright, so that's solved, but now I can still see 4 issues in main.go. So what we'll do is we'll go ahead and run this again. Here now we can see some issues from main.go file, and the first one is on line 50. Okay, and then on line 66, and then on line 87, print, line 102, right? So what I'm trying to show you here is, if you're working with technologies like Golang and Rust, you don't have to worry at all about making mistakes in the code. So don't depend too much on extensions, right? So many people would tell you get extensions that help you not make any mistakes in the code while writing the code, for spelling and for Golang. So I would suggest don't depend too much on that. As you can see, I wrote everything myself, and I just depended on the Golang compiler to tell me the issues, and I just solved them one by one. So just depend on Golang compiler, because when you're in an interview, when you're giving the interview for some company, you're not sure what kind of environment you'll get to write the code with. Mostly it's an online environment, right? And you have somebody on the call, you have an online environment, and you have to write the code in that online environment. That won't have the extensions that you want and that you work with. So it's highly recommended that you don't depend on extensions. I've had many of my friends get into a lot of trouble because of that. But know how to work with the Golang compiler a lot. Like, get very, very good at debugging code. Okay, so now things should work. So it says, it asks me to enter the password, and I will enter the password. It will ask me to confirm the password. I'll confirm the password. It will say file successfully protected. Try to open up the file. I'm not able to. Okay, and now what I'll do is I'll just run this again with, instead of encrypt, it will be decrypt, and I'll just enter the password I had used earlier. And now, as you can see, I can check out the file. I can look at the file. Okay, so this was our project. Everything works perfectly fine. Thank you so much for watching. This, I would say, is an intermediate level project. It's not very advanced. It's not very simple. Like, it's not a beginner level project probably, and it's not an advanced project also. Somewhere in the middle. But I hope you learned a lot. Thank you so much for watching. If you haven't subscribed to this channel, make sure you subscribe. I'll come up with awesome content like this in the future. Thank you so much. We're building something really interesting in today's video. What we'll do is we'll just take some plain text, encrypt it. We'll get the encrypted text. We'll then run it through a decryption function, and then we'll get the decrypted text. So it's quite straightforward. It's something we haven't done before on this channel. Right? It's working with encryption algorithms. So we're using a very simple encryption algorithm called the Caesar cipher in this project. And let me give you a quick demo on how this works. So if I run go run main.go, my plain text that I had given to the program was hello world, and I get the encrypted text, which is CZGGJRJMGY, and when we decrypt it again, we get hello world back, right? And in the program itself, you can give it some text that it will encrypt and decrypt. You can also build a CLI on top of it to accept the text from the user. I haven't done that because in this project, I want us to focus only on the encryption and decryption part. We don't want to focus on the CLI part because I've already done that in many other projects. Okay. So how this is working is, we first take some text, hello world, right? And by the way, this is very quick visual planning that we'll do before we actually start programming, so that we know exactly where we're going. And this is just a quick demo to show you how we're going to build it and what exactly is it that we're doing. So we have our text hello world that you saw in the demo, and we give this a key 5. So this key can change to be 7, could be 10, whatever, but in my case I'd given it the key 5. Okay, and I'll tell you what that key means. So with Caesar cipher, what happens is you pass in, let's say, all the alphabets. So in my case, in my program, I had passed it all the alphabets. You can also pass in numbers to this program, and you can also give it special characters. And what we want to do is, with Caesar cipher, we want to replace this text with some other alphabets from the alphabets that we have given it, right? So this one is going to be called as the original text, because from this we will select some other characters that will basically replace this text of ours, right? So in the end you get something like this, which is CZ EGJRJMGY, which is the encrypted text which nobody can understand, but when you decrypt it, the person who's supposed to receive this will get hello world back. Okay. And by the way, in the beginning of computation, this is how many encryption algorithms worked. And now you have obviously much more advanced algorithms, and that's what you see when you see WhatsApp saying it's end-to-end encrypted. They're basically encrypting all the text that you're sending, and you're getting back, the user is getting back the actual text, but then there's some encryption happening in between so that nobody can intercept those messages and read the meaning, read those messages basically. So the way this is working is, first we'll take 26, which is the length of all of these, all of the basically characters that we have sent, the original text, length is 26, and then we'll subtract the key, which is 5, from that. Okay, and then we'll create 2 different versions of this original text. One is from 0 to 21, because if you subtract 26 from 25, you get the number 21. So from 0 to 21, you'll separate that into a different bucket, and from 21 to 26 you'll separate that into a different bucket, right? And then what you do is you attach this in front of this part, right? So the one from 21 to 26, you attach that in front of this, these remaining digits, or the remaining alphabets or letters, and you get something like this. So this is something called as the hashed text. And essentially what you have to do now is you have to take H and find a corresponding or an equivalent letter from here that will basically replace H. Okay, so how do you do that? First, what you do is you find the index of H in the original letters. So you go to the original letters, which is the original text, and you find the index of H. So it's A, B, C, D, E, F, G, H is H. This is H here. So it's, the number is 7. So that's the index of H in the original letters, which is 7. And then you apply this formula. This formula basically gives you the this formula will give you the result of the index of the corresponding alphabet that you have to pick up from this particular text, the hashed text, right? So you get, I'll repeat again, you get the position or the index of that number that you want to encrypt from the original text, and then you run a formula and you get, this is the main formula for cipher algorithm, and then you get the position or the index of the alphabet in the hash text, and that's the one that you want to replace this with. So in the hash text, right, so firstly let's run the formula. So the formula basically says the position in the original text of H, which is 7, plus the length of the original letters, which is 26, and modulus with the length of the original letters, which is again 26. And the answer that you get here is basically 7. So in our case, the index of H in original letter was 7, and the index of the index from the formula that we got by running the formula is again 7. So we have to look for the 7th alphabet in the hash text. So it's like 1, 2, 3, 4, 5, 6, and then 7. 7 is B in our case, right? As you can see, B. So we replace H by B. And similarly, you can run E, which is hello world, right? That's the text we want to encrypt. So E, you take E, and then you do the same thing, and what you get is E will be replaced by Z, right? So Z is, and how that happens is because in the original text, E is the 5th digit, right? So when you run this formula again, you'll get 5 here. And when you go to the 5th digit here, 1, 2, 3, 4, 5, Z is the 5th one, so that's why you say 5. And now you don't even have to run the formula, you can just get all the other digits very easily because L is the 12th, right? So if you go to the original text, so L is the 12th, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, L is the 12th. And that's why in the hash text also, you will also look at the 12th alphabet or the 12th letter. So it's 5, 6, 7, 8, 9, 10, 11, 12, which is, in our case, it's G. So that's why both the L's have been shown as G out here. Okay, and then you can get the others also really easily. And this is how basically this entire algorithm is working. Now, this is very predictable. Like if you give this to somebody and they figure out like the corresponding of H and E, for example, in this, they can easily figure out all the other letters. And this is a very, very simple encryption to break. It doesn't take a lot of brains to break this encryption. So that's why this is like the simplest encryption that I wanted to show you. And then you've seen my other videos on the blockchains and how we've used SHA-256, right, to encrypt. And those more advanced algorithms have more advanced properties. You have the avalanche effect, and you have what's the other term? I'm forgetting the term. It's basically, but the property is that no particular letter corresponds to another letter, right? So that property is called something. I'm forgetting the name right now. But the avalanche effect again is that if you change one thing in that encryption, everything, the complete signature changes. So you have those advanced properties that you get with advanced algorithms. You don't have any properties with this. This is like very straightforward. This has existed from the time of Caesar, I think. That's why it's called Caesar cipher. It's like way before the invention of computers. But it's a great algorithm to know. It's great to get started with it in encryption. It's a great project to build with Golang because we'll work with this little algorithm, but we'll also get to apply our Golang concepts, and that's what will make us a better Golang developer. Okay, so with this out of the way, let's get started. Now, before we get started, I just want to tell you that this particular video will be part of the 47 Killer Golang Projects series. So I have this playlist on my channel. It has 47 projects in Golang. So in case you didn't know that, you might want to check them out. So this 47 will now become 48 because this video will be there in that. And what I'm trying to do is I'm trying to arrange these videos in the level of difficulty. Where some of them I've still not arranged them in the right order, but I will do that. And then eventually they will be in the right order of difficulty. And you want to start from the beginning and start building projects one by one. All right, that's how you want to go about these. Now, the next thing I want to tell you is that we have this Discord server for my YouTube, and everyone is allowed here, and we discuss really awesome stuff like what we're learning today, and we're having a lot of discussions. So like, let's say if you have any Golang issues, you can come here and post the issues, and we're discussing about any issues about Golang. I help quite a bit on this community, so if you want, you can join it. All you have to do is the link I think is out here, so you have to just go here, and this is I think the link for joining the community. If you're not able to join it, let me know. I'll make sure I'll send the new link with you. Okay, so that's one more thing I want to share with you. And the code for this particular project and all the other projects is on my GitHub. So in case I don't share my GitHub link with you, you have to know it's Akhil Sharma 90 on GitHub, and you'll find almost all of the projects here. This is the one that we're building today. Sorry, not this one. This is the one that we're building today. Simple encryption decryption with Golang using Caesar cipher, right? So the code is already there. All you have to do is just come here, and in case you get stuck, you just have to refer to that code. All right, so everything is clear now. Now what we have to do is we have to, I will just go back to my, the place where I keep all my Golang projects, and I will just create a new directory. I'll just say go encryption YT, okay, and I will cd into it, and here we will go mod init, and I'll just say github.com/Akhil Sharma 90 /go encryption writing. So what this does is for us is it creates a go.mod file which will have the list of all the modules that we'll use. In this particular project, we're not using any third-party modules, I think, mostly. So you don't need to worry too much about it, but still we'll just have it in any case. Here I'll just create the main.go file. And this is a very small, straightforward project. There's not a lot of engineering in this, but it's small and straightforward, like I said, and it's a great project to build, like great beginner level project to build. So in my main.go file, I'll just say package main, which is the first thing you write anyways in your main.go file, and then I'll have some import related stuff, right? So I'll just write import here, and then accordingly I'll import the stuff that I want to import. I'll have the main function, obviously the func main, and here is where I will define my plain text, which in my case is hello world. You can change it also, and then I'm going to print it out. I'm going to print out the plain text as it happened in our demo also, right? Same way, plain text. I'm going to print out plain text. Then we have our encrypted text, which is what we're going to get when we call our encrypt function that we will create now. So we'll create an encrypt function. It will take in the key. In my case, it will be 5 and the plain text, right? So this means that here, up here somewhere will be our encrypt function. So we'll say func encrypt, and it will take the key, which is the integer, and the plain text, which will be string, and this will return to us the result, which will be the string, the encrypted text, obviously, right? And then obviously apart from the encryption function, if we have an encryption function, we also need the decryption function. This will again take in the key, the encrypted text, and is going to return back the result, which is the string. So once you've encrypted it, you have this in this variable called encrypted, and we will print it out first. So we'll say print ln encrypted text will be encrypted, and then we have decrypted is equal to decrypt 5 comma encrypted, and then we'll print it out decrypted comma decrypted. So to the decrypt function, you are passing the key and the encrypted text, and you'll get that in the decrypted variable, and then we'll just print that out. So that's it. That's all our func main is doing. Okay. At the top, I will say my original letter will have all the 26 A, B, C, D, E, F, G, H, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay. So my original letter will have all of this. Original letter basically means this, the original text. This has all of the letters. This is the plain text, and this is the key 5 which we've passed. Okay. Now we want the hashed text. So for the hashed text, we need another function. Let's call it func hash letter function. Takes in the key, takes in the original letter. It will take in the original letter, and we'll say result and string. Okay. Now here the first function that's called is the encrypt function. So we'll start building upon the encrypt function. So as you remember, in the encryption part, the first thing we do is we first want this, right? And then we'll find the index of H, the first letter. We'll start letter by letter. In the first letter, which is H, we'll find the position of H in the original text. But we also want this, right? We want the hash text, because after we run our formula, we want to find that particular index, what's the value at that index in our hashed text. So that's why we need this also first. So we'll call the hash letter function. So we'll say hash letter function. We'll pass it the key and the original letter being this. We'll just pass it there. And to start with, we'll say var hashed string is equal to empty. Now hashed string is what we want to return from here. So that's this result that we are sending back is the hash string, and one by one we will keep adding to this empty string some values. So for example, for h, the first value in our case, as you saw here, we'll get c, right? So whatever we get here, c and z and g. So one by one we'll keep adding values to it. We'll run things through a loop and we'll keep appending things to this hashed string, and that's why first we'll start with this being empty, and then we will run actually at the end here we will have this function called strings.map, and we'll say find one comma plain text. So strings.map, what this does is it takes in the plain text. Okay, in our case the plain text is actually hello world, so it takes in hello world, and one by one it will send it and call this function called find one. So it will take h first and then e next, l, so it will take all these things one by one, strings.map, and then call the find one function. So what is find one? So find one is equal to a function, it's a function which takes in R as a rune and returns a rune. Now what does that mean? So runes basically help you with Unicode. So what we're saying here is that a rune represents a single Unicode character. Okay, so for example, A, the value of A is 65, so you get the ASCII2 value, and now you can work with the letters in a much more flexible way. So you get separation between all these letters. So for example, A, B, C, D, E, F, because you're sending them one by one, but then with rune you're able to work with them in like much more easily, because here what we have not covered is that the runes that you will get here also you'll use rune to be able to work with that. So we'll be using rune basically all throughout to be able to iterate over all these letters and work with those letters and then perform operations on that. So it will take in our rune. So for each letter like H, we take each letter from the plain text, which is like the hello world, right? So H, we take that and we send it to find one, and then what the find one function is doing is it's taking in that H and returning to us the equivalent letter in the encrypted text. So in our case it will be C. Now how do we get from H to C? Let's take a look. So first I think I'll just build the hash letter function, because otherwise there will be just confusions, because I wanted to explain the rune part before we wrote rune here, because we are using it in the hash letter function, so I didn't do that. My bad, but I think I'll just build this function before we work more on the encrypt function, so that it just makes more sense. So this hash letter function, right, all it's supposed to do is it's supposed to take in this key and then divide this into from A to U and from V to Z, divide the original text into these two parts, and then also put this in front of this and then return that part. So we want to return the hash text of this function. So we'll say last letter key equal to string runes length of letter being original letter in our case. So from here to here the length is obviously 26. So we'll say length of letter minus key to length of letter. So this is runes of 21 is to 26. So from 21 to 26, what are the things, which is in our case 21, 26, V, W, X, Y, Z. So these 5 things will basically come in the last letter key. And then we'll say the leftover letters, left leftover letter is equal to string runes and 0 length of letter minus key. Okay, so 0 to 21. So this is length of letter, which is 26, minus key, which is key is 5, so it becomes 21. So 0 to 21 will come in one place, like I said, and 21 to 26 will come in another place. So this has 0 to 21 and this has 21 to 26. So last letter key and the leftover letters. Now all we have to do is we have to return. I told you, right? We'll return this plus this. So we'll return the last key letter and followed by the leftover letters. So let's do that. So we'll say fmt dot sprintf. Here, let's say %s and %s. Comma last letter key, comma leftover letters. So we are able to return what we promised from this function, which is the string, which is the hashed text from this function. So in the encrypt function, we were now in the find one function, and here we will first start with the position. Strings dot index. Why the position? If you remember, I had told you that what we'll do is we'll find the index of h or the position of h in the original letters. That's how we'll get 7, right? So this is the original text, and we have to now find the index of h there. So it's a strings dot index and the original letter, comma string, and that there will be rune r. And now we will get the position of that letter. Now, what if the original text that we passed, original letter text that we passed, somehow we forgot to write, there was a typo, we forgot to write h there, right? Then position will basically become -1, and that's what we want to check for. So we want to check if position is not equal to -1, that means the letter that we want to encrypt is actually existing in the original letter. We want to find the position. If it's not equal to -1, then we can do something about it. Otherwise, it's a problem, right? Otherwise, you just want to return the same thing, return r. And finally, from here, we want to return the hashed string, as you know, hash string, which is now empty. We want to fill it up. So if everything is all right and it's not -1, then we'll say letter position is equal to position plus length original letter percentage length of original letter and hashed string is equal to hash string plus string of hash letter position. Okay, so what's happening here is we first find the position and then we run our modulus function. So if you remember, I told you the function or the formula looks something like this, where we add the position plus the length of the original letters, and we run modulo, which is length of original letters. So in our case, it will be 7 plus 26, modulus of 26, we get 7, right? So that's what we're doing here. So you get the letter of the position, which is 7, and now the next step would be to look for that letter which is at the 7th position in the hashed text, and that's what we're doing. So we're looking in the hash letter that we have, hash text, we're passing this letter position and getting that particular value, converting that into string and adding that to hashed string. So each of these values from the plain text, one by one, because of the help of strings.map, one by one we'll take it like h and e and l and o, and then we'll pass it to find one. Find one is accepting it as a rune and also returning a rune in our case, and then it's adding everything to hashed string. That's what's happening, adding everything to hash string. And finally, we'll have hash string that's what we'll return from this function. Okay. Now the decrypt function is going to be the exact opposite of this. The decrypt function is going to basically have the same method, which is calling the hash letter function, and we'll capture that value in a variable called hash letter. So the hash letter function will pass the key and the original letter, and again we'll start with the hash string, which is empty. So with the decryption, we have to find again, you know, that value in the hash letter index. So this is what we'll start with, okay, in the beginning, and we'll find the value of, let's say, C. So in the encryption, we started with the original text. Now we'll start with the hash text. So let me write it here. This is decryption. Sorry. You start with the hash text, and you see that the H, right, is of particular value, and this is the original text here. Yeah, so like I was saying, this will happen before. So we'll first check the value of that letter here. Let's say in our case it's C, right? So we'll notice the value is 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this will be 8 in our case, right? And then that 8 we have to find in the hashed text. In the original text. So the original text is different, right? So decryption will exactly be the opposite of encryption. So in encryption, we first found the position of the value in the original text and then found an equivalent in the hash text. In decryption, will be completely opposite. We'll first find the position of that particular, so C, for example, we'll first find the value of that letter in our hash text, in this case C, and then with that position we'll run that formula again and we'll get some value, and then that value we have to pick from the original text, and that's how we'll get back hello world from this text. So that's the entire method that we have to follow now. Okay, so let's do that. So for decryption, we say hash string is completely empty, and then we say find one. And who's going to call find one? Out here we'll just say strings.map find one, comma, encrypted text, and return hashed string, right? So the other thing that's changing here is that with encrypt we sent the plain text to our find one, but in decryption we're passing the encrypted text to our find one function. And then find one function, we'll say func or rune and rune. Okay, so that was one change, which is passing plain text versus passing encrypted text. The other change, which I was showing you in the diagram, was that we will find the position of the word in its hashed letters. So earlier we found it in the original letters, right? The first position. Now we'll find it in the hashed letter, and we'll say string rune r. And again we'll check for the same thing, position is not equal to -1. We'll check for the same thing. So here we'll return R. Yeah, this if you remember, we're checking because that particular value that's coming in here needs to be there in the hashed text, right? So not the original letter, in this case is the hash letter, so it has to be there in the hash letter, the position, otherwise it will be -1. So only if it's not -1 we can proceed. And this is how we'll proceed. So we'll say letter position equal to, we'll again apply the formula plus length of original letter percentage length of original letter, which is modulo and length of original letter. And we'll say hashed string is equal to hashed string plus string and original letter position. Forgot the return R here. Okay. Right. So main differences in decrypt and encrypt is, like I said, we're passing the encrypted text here, we're passing the plain text there, and here we're checking for the position in the hash letter being this one, and here in the encryption we're checking for the letter position in the original letter here. For finding the letter position formula, we use the length of original letter only. That's not different. That's the same thing. And finding the hashed string, finally at the end, we found here from the hash letter, we found the equivalent text, and now to decrypt it back, we're finding it from the original letter, the equivalent letter. So here we'll get back to decrypted text. Now I don't see any issues or any errors here in the code. So what I'll do is I'll just go here and I'll just say go run main.code. So if there are any errors, we'll get them here, but there were not any errors, luckily. So we had our plain text, we got the encrypted text, and we got the decrypted text. Okay. So I'll just quickly go over it again in case you missed anything. We started with our plain text. We got the encrypted text, which is this. We sent it to the decryption function, got the decrypted text. Started with hello world text. We want to replace each single letter with different alphabet. The key that we passed was 5, and the original text we passed was this. So this can have numbers, this can have small characters also, this can have special characters also. And when we pass the key as 5, we run this through the original text through a hash function, which basically subtracts 5 from the length of the original text, so we get 21. So we divide the original text into two different parts. One is from 0 to 21 and from 21 to 26. Then we pass the hash text back, so which is this before this text, and we pass this back to the function. In the encryption function, the first thing we do is we find the index of the first letter, which is H, in the original text. So in this case we get 7. Now we run our formula, which is position plus length of original letters, percentage or modulo length of original letters, and then we get again 7, and we find 7 in the hashed text because we want to convert from original to the hashed or the encrypted. So we'll find an like a corresponding number digit or letter from here, and B. So we found that H is equal to B because B is on the 7th position after we ran this formula, and that's how from hello world we actually got this. In this decryption it works the completely opposite, because we find the position of C first in the hash text, and then we get that position, and then we basically run it through the formula, and then we get the original text. And we get the position in the original text of that corresponding letter. In this case it will be H. Now guys, there's one thing that I have made a small mistake in, right? So, and I want you to find that out in case you haven't figured out in the whole program. One thing that I've been missing and messing up with, just so that in case you've understood it, please let me know where I've made that mistake. That'll basically ensure. So if you go through the video again, look for the mistake, things will become much clearer to you, and you'll be able to completely understand this concept, right? So let me know if you found that mistake. I'm going to tell you the answer anyways, in case if you have not found it. So the mistake is that the value, the actual position of h is not 7. It's 1, 2, 3, 4, 5, 6, 7, 8. It's actually 8, not 7. So that's why you have to write here 8, and you have to write here 8. You have to write here 8. Then you have to write here 8. And should have in C, right? H should be equal to C and not B. And that's how you get C right here, right? So I made that mistake. And now you can actually go and run the actual values and you'll see everything is consistent. All right, so that's perfect. I hope you were paying attention now. Now when you look at the mistake, everything will make sense, right? So, so what I want you to do is I want you to run through the entire code once again and run through those values once again so that you basically internalize whatever I've taught you. Try to put different values here like smaller text and then special text characters, all of that. Try and see how that works. And thank you so much for watching this video. I hope you will join our community on Discord where we'll get to hang out, and you'll watch all the other videos in this in the Golang playlist. All right, so thank you so much, and I'll see you in the next video.